Mudryi, and today I will talk about our research Precision versus Perturbation, Robustness analysis of synonym attack in Ukrainian NLP. This research was done by me, Volodymyr Mudryi, and also my advisor, Oleksii Ignatenko. So let's start with the question why we should care about robustness. Sometimes we can just take a model, fine-tune it on a dataset, and achieve pretty good accuracy of 98% of. But there is a question, how robust this model? So, for example, we can have two samples. Like once this movie was absolutely fantastic from start to finish, and another one, this movie was absolutely marvelous from start to finish. So we replace only one word. In both cases, human will say it's a positive review, but model can be tuned in such way that first one will be predicted as positive and second one will be predicted as negative, which is a potential drawback. It's getting even worse in Ukrainian, where we have like rich morphology and pretty complex language. So, for example, бравлярійські кабелів однозначно краще бокорізів, але гірше болгарки. We replace однозначно ту формально. Бравлярійські кабелів формально краще бокорізів, але гірше болгарки. And model prediction changed from like 4 out of 5 stars to 2 out of 5 stars, from a good review to a bad one. So it can be a really problem. Also, when we just replace one word, the accuracy can drop like from 98 to 86%. So it's only with one word. So it's a real problem. In our work, we focused on firstly adapted TextFooler and BERT Attack pipelines for Ukrainian. TextFooler and BERT Attack is one of the most popular synonym substitution pipelines in English one, so we adapted for Ukrainian. Second one is benchmarked robustness of 3 models, Ukr RoBERTa, XLM RoBERTa, and sentence transformer SBERT on 3 different Ukrainian datasets. And third one is evaluate transferability of adversarial examples to ChatGPT. So if modern models also have this problem. So let's start with experiment setup with datasets that we used in this research. First one is UR reviews. Is reviews scrapped from Foursquare or Rosetka or whatever. So it's like 15,000 records, and we need to predict for a score from 1 to 5, how good the review is. Second one dataset is UR News. Is UR News headlines. Is multi-class datasets that need to predict by headline of the news which domain of it is, like sport, politics, and whatever. It's a pretty large dataset of 150,000 records. Third one is datasets based from this year UNLP 2025 shared task about manipulation, but we simplify it and we don't want to predict each manipulation technique. We just want to predict binary if there any manipulation text or not. So it's pretty small dataset, but it's have like a pretty large average length. Like 82, in average, 82 characters per sample. With all these 3 datasets, we fine-tuned 3 models. It's like Ukrainian RoBERTa, XML RoBERTa multilingual version, and sentence transformer, also a multilingual model that is Ukrainian in a train set. You can see that all the models on all the datasets show pretty good results. It's like in UR reviews, it's up to 77%, in UR News is like around 93%, and UNLP 2025 is higher than 80%. So with all these results, we start with naive approach where we just replace one word to a synonym, and even with one word replacement, we can see that there's a huge difference. Like sometimes model performance dropped by 12%, which is like a lot. For sometimes it's like 2 or 5%. So one word shows that this problem is real in Ukrainian language and Ukrainian models. With that, let's go deeper with our methodology, how TextFooler and BERT Attack works for Ukrainian. First of all, we have input. Дійсно дуже якісний теплий костюм. It's really high quality and warm suit. And prediction is like 5-star review. It's 96 prediction probability. First of all, we need to get word importance. We do it via leave one out. So we just drop one word, like first дійсно, and we leave дуже якісний теплий костюм. or дуже, дійсно якісний tablet costume, and so on and so on. So for each of word, we drop it and measure the prediction probability. Where the prediction probability change the most dramatically, that we'll consider as first word to replace. Like this one, when we drop word якісний quality and prediction probability drop from 96 to 49. Second step is get all the possible replacements. So we give as input our word, якісний quality, and we want to get all the synonyms. Відмінний, хороший, гарний, тривкий, and so on. How it's done in like original research. TextFooler originally used fine-tuned fast text embeddings. Unfortunately for Ukrainian, we don't have such fine-tuned fast text embeddings on synonyms. So we tried regional fast text embeddings, but unfortunately it's not capture the synonyms. So in this example, we try to get synonyms for most similar words to word приємно, and we get неприємно, like totally antonym. So fast text is not a well-suited one. We decided to solve this problem with using synonym dictionary scrapped from synonym info. So we have a pre-built dictionary that have synonyms, and we will pick our synonyms from this dictionary. On the other hand, on BERT Attack, originally used a BERT mask language model. So we just mask a word and ask to predict it, and all the possible candidates is our synonym. For Ukrainian, we use XLM RoBERTa large because it's like have a better performance. With all this generated candidates synonyms for replacement, we need to generate replacement. So we replace our word якісний, quality, to word хороший, good, тривкий, durable, and so on. And with this generated replacement, we select the one with a higher prediction probability drop. Also, a few words about generating replacement. To keep a quality of this replacement high, we include two filters. First one is sentence similarity. We measure similarity between original sentence and replaced one. In original work, it was done by using universal sentence encoder. Unfortunately for Ukrainian, we don't have this one, so we utilize a sentence transformer, paraphrase, XML multilingual. And we keep only those replacements where cosine similarity is higher than 0.7. And second filtering, that's word similarity. Originally measure similarity between original word and replacement word synonym via fast text. We utilize Ukrainian fast text and keep substitutions that have cosine similarity higher than 0.33. Here are our results on TextFooler attack. We have like 3 different datasets, 3 different models, and we have original accuracy, adversarial accuracy, drop, change rate, and queries. You can see that the drop for some datasets like reviews and UNLP is higher than 30%, while we change like around 14 or 10% of sentence. So it's not a lot. In other hand, for UI News, we changed 20% of a sentence, but drop is only like around 10-15%. Second results, in results of the BERT attack, the results are like worse because the drop in performance is much smaller. If you can see, here is like around 30%. Now here is like around 10-20%. So, but change rate is much smaller. So if we have for TextFooler around 15%, here we have around 4-3%. So each have a less changes and therefore less drop in performance. And here's like summary of results. First of all, XLM RoBERTa is most robust model, average drop around 20%. So it's pretty good results. The second one is the TextFooler approach have much more successful attack, 26% in average versus 90% from BERT attack. And third one, TextFooler replacement keeps semantic similarity better, but have a problem with keeping correct grammar form. You can check in our article some examples of that. And last but not least, we measure a GPT-4o performance, and even like modern model like GPT-4o for Ukrainian language have pretty low original accuracy for like reviews or news, and also like drop is still exists. For example, for news there is no such drop, but for reviews is around 15 or 8%. For UI news is like around 10% for BERT attack. So it's still a problem, and modern GPT-4o not solve it fully, and this like a good evidence of that. In the end, we have like a following. We adopted TextFooler and BERT Attack for Ukrainian, addressing morphology and synonym quality. We improve robustness. We measure robustness dropped by 40%, and even GPT-4o remained vulnerable, like -7, -15% of accuracy drop. One of our future work is to incorporate more sense-aware attack, hybrid LLM pipelines where we use LLM to rephrase, and we want to standardize the Ukrainian Robustness benchmark to be developed. Content benchmark are available by the link. Thank you for your attention. Bye.